So dear student, you know already that there are two types of charges. One is positive and another one is negative. The positive is contained by protons and the negative charges are contained by electrons. And when these charges flows from an circuit or any wire, that produces our electricity. So students, I will say a little bit extra things that is out of your syllabus. So the electrons, mainly electrons, flows from the electric circuit or from any wire and not the protons, that is not the positive charges. Suppose if I take a wire and if you are thinking that the only positive charges flows from it, suppose it is from A to B, positive charges flows or protons flows, so that is a wrong concept. But the original concept is from A to B only electron flows. It is the correct concept, or you can say it is the right thing that flows. But during the discovery of the electricity by the scientists, so they assume that only protons flows from the wire and not the electrons. So positive charges flows from the wire and not the electron flows. So this concept we will be carrying out in this chapter also. So here first topic of our chapter is electric current, or you can say electricity, and the rate of flow of electric current, or you can say electric charges also. So the rate of flow of current in a particular area, or you can say or in a circuit, that is the definition of electric current. So we are getting here one formula of electric current, that is current is equal to charge per time, or for current we can write I, charge Q, and for time T. And if we see the SI units, so the SI unit of current that can be symbolized as I is ampere, A, SI unit of charge Q is coulomb, C, and SI unit of time T is second. Okay, so these are the SI units. So next is our about the ampere. So ampere was discovered by the scientist that's name was Andre Marie Ampere, or Andre Marie Ampere. And if I take 1 ampere, so 1 ampere, when 1 ampere will be, so 1 ampere is the flow of 1 coulomb of charge from an electric circuit per second. Okay, there is the definition of 1 ampere. That is 1 ampere is equal to 1 coulomb upon 1 second. And if we use 1 electron, so 1 electron contains the charge of 1.6 into 10 to the power minus 19 coulomb. There is a charge contained by 1 electron. And if I take 1 coulomb of charge and it contains 6 into 10 to the power 18 electrons. Okay. So we can take one question from it, whatever formula we have got, that electric of 2 ampere passes through a wire for 2 minutes. Find the total charge passed through the wire. So solutions will be, so first of all, what is given in the question? That is the current I equal to 2 ampere, and we can write 2A. And next thing given is the time, 2 minutes was given, so it has to be changed into its SI unit, that is second. So 2 into 60 we have written 120 second. So we have got the formula I equal to Q by T. So I is already given 2 coulomb, we have to find out, that means the charge. So T is 120, so Q will be equal to 2 multiplied by 120. So here we are getting the charge Q is equal to 240 coulomb, and this is our solution. So students, some question may revolve in your brain that how the charges flows from the wire, that is the positive charges, that is protons, how it flows. So the answer is as simple as the floating of water or flowing of water from a pipe. So this happens due to the differences in the high pressure and the low pressure. That is, in one part there will be high pressure, and if another part low pressure is there, so this difference, due to this difference in the pressure, it causes the charges or water to flow from one part to the another. And this difference in the wire or in the charges, it is called as the potential difference. And this is our next topic. So generally, potential difference occurs due to the presence of cells or batteries. Now we will understand the definition of electric potential difference. Electric potential difference. That is our next topic, second topic of the chapter. So it is the difference between the 2 points in moving a unit charge from one point to the another point. And so for doing this, some work is done, and that work gives us the potential difference. So that work, whatever goes on, will brings the potential difference in the cell or in the circuit. Now we will have one formula for the potential difference, and that is, by the definition, we have got work upon charge. So if potential difference can be written as V and work W, then it will be V equal to W by Q. The SI unit of potential difference is volt. It has been given by the scientist Alessandro Volta. Now we will discuss the definition of 1 volt. What do you mean by the potential difference as 1 volt? So that will be 1 joule of work is done in moving 1 coulomb of charge. That is 1 volt. So here in short form we can write 1 volt is equal to 1 joule by 1 coulomb. Okay. So from this formula we can solve one question here, that is, find the work done to shift 4 coulomb charge from A to B if potential difference between A and B is 10 volt. So the solution will be, first we will write the given part, that is V equal to 10V, and Q is given for C. So V means potential difference, Q is electric charge. So we are getting the formula V equal to W by Q, as we have done already. So V is given 10 and W is given, so no, W we have to find out. So C, that means the coulomb, that is the charge, that is 4. So W we are getting as 40 joule. Okay, so this is the solution. So now we will see some quantities or some values, that is 1 milliampere is constituted 10 to the power minus 3 ampere, and 1 microampere is 10 to the power minus 6 ampere. So some words we are getting here, that is ammeter and voltmeter, what they are. So ammeter is used to measure electric current, and the another one, that is voltmeter, is used to measure potential difference. So students, this is all about episode 1 of electricity chapter. So we have done up to here, and we will see more things about this chapter in the episode 2. So please subscribe to know more things about this chapter. Thank you and stay safe.